Let's make sure this thing works first. All right. Everybody still awake? It's the final countdown, right? It's the last stretch of the day. Quite possibly the worst time slot in the afternoon, but that's all right. Hopefully I'll keep you interested. So my name's Aaron, and I'm going to talk about how I use Puppet. People still use Puppet, right? I've heard a lot of mention of Salt, and I've heard a lot of mention of, we got a Puppet guy up there, a lot of mention of Chef, but people still do use Puppet, right? Okay, good. I'm going to talk about how I use Puppet in a little bit different of a state than most folks do, simply because of some ramifications that we'll explore. But all the Puppet work that I've done at Adaptive Computing is in a masterless state, meaning I'm not using Puppet in its traditional client-server model, right? I'm not managing a nodes file. I'm not signing certificates because of some ramifications that I'll show you as we get into things here, okay? So just keep that in mind. A little bit about me. These are some things I like to do, and some history on me. I've been in operations, if that's what you call it, for 15 years. Usually it's just, hey, something's broken, please fix it, right? I'm sure all of us can relate to those type of comments coming from our users. I'm an automator. I don't like unrepeatable work, so that leads into bullet number 3. My colleagues might say that I am a finder of silos and other unrepeatable work. A typical accolade that I subscribe to is if you get hit by a bus, if you walk out and get hit by a bus and it's not repeatable, none of your work counted for anything to me, right? I want it repeatable. I don't want to have to go dig into your code and figure out how to do it. I want to be able to deploy it. I want to be able to reuse it on the fly, right? So if it can't be repeated, it doesn't count. I'm passionate about DevOps culture simply because of the people, because all of you are smarter together than individuals are, right? I'm not that smart of a person, but together with other like-minded people, I think we can come up with some pretty cool stuff. So I really like DevOps culture. I like the tools. I think the tools are great, but at the end of the day, it's the people. It's all of you, right, that get things done, and that's what's important. Puller of strings, both Puppet strings and guitar, right? I'm not very good at the guitar, and some say I'm not very good at Puppet either, but I try, right? And I get a little bit of enjoyment out of it. Recently got back into motorcycling. It's kind of funny to see a big guy on a bike, but it can be done. I had a bike when I was a much younger, less intelligent person, but I've recently got back into it. It's a lot of fun. And then if I do some of these things that are at the top of this list, and I do them well, specifically my career, that gives me time to do what I ultimately enjoy, and that is being a husband and a father. I have 2 little girls, a beautiful wife. It's much rather spend time with them than with my colleagues. Not that my colleagues are bad, but I like to go home at night and know that things are going to function, right? So I work for Adaptive Computing, and what's Adaptive about? Adaptive Computing manages the world's largest computing installations with its Moab self-optimizing cloud management, blah, 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 blah. That's a marketing slide. Can you guys tell a marketing person wrote it? Right? So Adaptive's on the world's largest supercomputers. That's what you need to get out of the slide. And what that really means, I've listed out some of our customers. What that really means is that we do some kind of cool stuff that I get to take part in a ever minute way. NOAA, I had to look up the acronym because NOAA, National Oceanographic, whatever it is, right? But we predict the weather. That's kind of important to people. Anyone that remembers Hurricane Katrina or Sandy or some of these other life-threatening weather emergencies care about knowing when the weather is going to change, right? So we help predict the weather. Digital Globe is a company that does a lot of cool stuff. They analyze large sets of data from satellites all over the globe. One of the things they're doing right now is trying to locate the Malaysia Airlines flight. So that's meaningful work. That's pretty cool stuff. Hospital for Sick Children in Toronto, trying to find a cure for cancer is some of the work that they do there, meaningful work. We also claim that we have an installation on Stephen Hawking's supercomputer at the University of Cambridge, searching for something about the universe. And then Boeing is another one of our larger customers. They do obviously data analysis for how a plane flies, what makes it fly better, et cetera, right? So some of our customers, and what that means is that I think we do meaningful work. I think we do some fun stuff. My history at Adaptive, I've been there for about a year and a couple months, I think. Chef was in place. It's not a chef hating talk, because that's not the point of the message here. But Chef was in a small little corner of the company. There was no advocates there was no DevOpsy type people for the product for Chef. It wasn't being maintained. It wasn't being evangelized. It wasn't being promoted or expanded outside of that group. So we were able to replicate the Chef work in Puppet. Some silos were prevalent, as I'm sure all of you have experience with that, silos being prevalent in your organizations. These ones at Adaptive were fortified. They were made out of titanium, and they were very hard to penetrate, right? They were impenetrable silos. And then because of that, because of the items above, there was these disconnected efforts between each of the business units inside of the company, which equated to a lot of waste. And we're in DevOps, right? We care about eliminating inefficiencies, and so the territory was ripe, if you will. So here's a little bit about the problem that I was trying to solve specifically. One of the things that was disturbing early on was that it was taking our own developers, the guys that work for Adaptive, days of time to install our own stack. Now, typically those weren't the uber cool developers. Those were the guys that were being onboarded, but the fact of the matter was that we were having a time waste of developers' time eating our own dog food, right? Installing our own product. Most importantly, none of those individual silos about how to do the installation of our own stack was reproducible. Nothing was automated. And then, to add insult to injury, no two devs did it exactly the same way. If you asked Tom, his way was the way. But if you asked Fred, as soon as Tom left, then he'd be like, dude, that guy doesn't know anything, right? This is the way I do it. And so I think we all say that to a certain extent. But you get the problem, right? We didn't have the way to do it, and it wasn't reproducible or automated. And then to add to that, this work that was not automated or reproducible wasn't even following to a T our own public documentation that we release to customers. And we care about our customers. We want them to have a pleasant experience with our piece of software, okay? And then these inefficiencies were kind of spilling over. We're overflowing the banks of productivity into other business units inside of the company. I've already kind of mentioned about that. So this is how I felt, right? One of the guys that I used to work for, Jake, is here in the audience, and I think I might have told him that it was one of the hardest places to do DevOps right, because we're not a typical DevOps shop. We don't deploy 100 times a day to production. Our release cycle is 6 months long. It's not a typical DevOpsy type shop. And so I felt like that, and I wanted to run, but I stuck it out. So we began searching for what was going to be a solution to some of these problems that we were able to identify, that I was able to identify early on at Adaptive. And so I turned to a tool that I had a lot of experience with. Worked for 6.5 years at a company called Spark Networks. They do niche dating sites. You've probably seen advertisements on TV for Christian Mingle or different sites like that. Worked there for a long time, utilizing tools like Puppet to make configuration repeatable, reproducible. Hopefully before all the other cool kids were doing it, right? I'd like to say that I was using Puppet before it was widely adopted. Glad to see there's still some Puppet people. But we ran into a couple of problems. And they went something like, and those that have used Puppet probably are going to be very familiar with this. Okay, let's spin up our new box. One thing to note is that we utilize OpenStack internally, right? That's a value add that we give our developers. We don't want to have them wasting resources via VirtualBox on their own machine. So we provide for them a means by which they can use OpenStack to build these images to test and to install on and to develop code on and whatnot. So you'd sign it, you'd kick off a certificate assignment, and pop in, wait for cert, and specify where your puppetmaster was, and then you jump over to the puppetmaster, and you do puppet ca -- list, and you may wait for a couple seconds, and then you'll go back to your client and do this again, right? And then you'll go back and check and see if it's there, and then you'll sign it. And sometimes you'll go back and make sure that you really did sign it, and that it got the right fully qualified domain name that's on the cert so that it matches when it goes back to the client, that everything's going to work. And then inevitably when a developer were kicked off an image on OpenStack from a snapshot versus a fresh install, and we'd run into a certificate problem. These were the type of issues that I started to run into as I was trying to apply a tool that I was fairly familiar with into a new problem set, new environment, okay? Now, those that are Puppet savvy are going to say, yeah, but you could regex. There's ways that you could get around this, right? You could regex your node file, right? We have pieces of our component stack that we need to apply before we install a suite and after we install a suite. Some of those are Java 6 versus Java 7, depending on which product we're installing, MySQL, ODBC, et cetera, et cetera. So you could just regex and say apply everything to anything that comes in, and then you could also say go ahead and auto-sign on your certificates. Well, I felt like that was fairly kludgy. I felt like it wasn't efficient. The other concern that I have is when you start to manage your nodes file via regular expressions, and then a developer comes to you right before a release and says, yeah, but I need to plug in this module, and I need to try this configuration and these 4 associated modules, and that becomes a little bit harder, and it's a manual touch point. I don't want to have to go touch a nodes file for all these stacks that I'm standing up inside of OpenStack for developers, right? And so there's some things that we could have done, but they weren't quite right for our environment. They weren't quite as effective as we wanted them to be, and at the end of the day, as I already mentioned, it was a touch point that I didn't want to have to make. I didn't want to have to touch something. I want it to be simple. I want it to be as easy as breathing. So here's what we identified that we needed. We needed to bring order, which is a difficult thing to do, to order things. It can take people years of time. We wanted the pieces that were going to be used in the stack to follow our documentation. We wanted it to be modular. We wanted to eliminate inefficiencies. And then we wanted to create some of these feedback loops so that as we did things differently in our documentation, then we would be able to eat our own dog food in that documentation. And as a result, be able to create these tight integration points where something changed in documentation, right? And then we're able to immediately validate it inside of OpenStack, going through the install process of our stack the way that we tell our customers to, and then we can get immediate feedback and validation that that's working, right? And then as some bonus items, outside of an engineering-centric role, others should be able to utilize our efforts, right? If I have a sales engineer in Taiwan and he wants to be able to use the same tool that I use in engineering to stand up a stack, he should be able to do that. It should be nothing more than a git clone away, right? If someone in sales wants to do it, right? So easy a sales guy could do it. By the way, that never works, right? But we wanted to make sure that anyone could do it, right? Anyone inside the organization should be able to utilize this tool. And then we also wanted it to be automatable via other systems that we had in place, namely Jenkins, right? We wanted to be able to call this via Jenkins script. So Jenkins, once Jenkins saw a commit, it could reach out to OpenStack and stand up our environment via a tool. And then we could do some testing via Nose. We use a Python toolkit called Nose to do our testing. And then based on whether or not that was fruitful, if the tests pass, and we can promote that build on down the pipeline, right? Stuff we're all familiar with. So this is what we needed. And so we built this. No, this. Well, it started out like, well, here's the deal. The important thing to remember from this slide is if you create a tool and you name it as something as benign as Builder, because I couldn't think of anything else to call it, I thought, well, it builds stuff, right? So I'm going to call it Builder. Then someone will come by your office cubicle and they'll put a picture of Bob the Builder on your cubicle window. And then forever and ever inside the organization, it'll be known as Builder, as Bob. So that's what we call the tool that was created. That one looks cooler, right? Doesn't it? Kind of. That one just looks so Weird. All right, so introducing Builder. Utilizes Puppet, that's probably pretty obvious. It's a wrapper that's built in Bash. It captures everything that's reported from Puppet runs because we miss out, because of the nature of masterless setups, we miss out by some of the value adds of client server, right? We don't get some of the reporting, et cetera, et cetera. It's modular, which is really, really, really important. So if a developer wants to clone the project and play with pieces inside of that stack, they can do that all on their own without any intervention from me or from anyone else. They can do that all on their own as they're testing and developing new different features and whatnot. That was a big one for us. Needed to be automatable, needed to be pluggable, meaning that there's things that we do that we tell our customers to do before an install of the suite and after. And then we wanted it to be awesome, right? I wanted it to be the one tool that everyone inside the organization eventually got to using. And I'm very proud that Builder is now the way that all of engineering, quality assurance, those two big ones, operations, but also these other business units, pre-sales, sales engineering, professional services, are able to utilize this tool and stand up stacks. All on their own. This is what a picture of the project kind of looks like. It's not out on GitHub. We use GitLab, which is an internal private-only installation, replication, if you will, of GitLab or of GitHub. So you'll notice, or what I want to call your attention to, are the AC apply and the M apply. These are what the M apply is directly what users interact with in a non-automated way. The AC apply basically takes anything that's been given by a user, if they've called it manually, and passes that into the AC apply to then initiate the run, the Puppet runs. The AC apply can also be given command line arguments, right? So we have an RPM that we release, but we also release a tarball, right? Everything can be passed into the AC apply script, and I'll show this stuff to you. But just to give you some background on it, everything can be passed into the AC apply script from, again, Jenkins, right? So when we finish a build and we want to test that, we pass these parameters into AC apply, and then via reaching out to OpenStack, we stand up the stack, etc. Right? Back here, one other thing to call note to, ancillary was what I deemed as all the places for our Lego bricks, if you will, all the pieces, all the modules. This is an example. Directory listing from the ancillary folder. We talked about things like Java 6 and 7. Different versions of our product depend on different versions of Java being there, right? So everything is modular. Moab is the name of our software, so we have a module that places that Moab file for us, right? Modular pieces, building bricks, right? So this is what the output from a mapply looks like. This is an output from just mapply, the shell script in general. You'll notice the options that we give users, right? RPM is assumed in the script, but we also allow them to test via tarball because we want to test those bits that we give to customers as well. Cloud, we also have a cloud offering, and then recently we've added the ability to replicate customer environments, right? So as our support team wants to test something, a bug that a customer is seeing, they can stand up a customer environment via Builder right there on the fly as well. So that's what the mapply script looks like. This is the kind of the most important piece out of the AC apply script. You'll notice that we set some custom factor variables, and then we have things that happen right? So we do things before we install a suite. And then we have an install section of the suite, and then we do things on a post-apply basis. Okay, so modular, Lego building blocks, pieces, right? This is the output of a run of the mapply on a machine. So you'll notice each of these are EL6s, right? That's because Factor has run. It has detected that we're on a CentOS system. It has detected the version of that CentOS system to be 6. And is only presenting for us the associated property files that we can actually install on our operating system. Okay, and so the other thing to remember about Builder is that it's property file driven. Okay, think pieces, right? We want to be able to do things before and do things after, and then have a consistent way to do things in the middle. This is an example listing of what some of the property files we have. Notice we have EL5s and EL6s in there. This is an example of the property file itself. So again, you'll notice we do things in the pre-apply section. We already talked about Java 7, so we apply Java 7. Because it's in OpenStack, we have to do some munging of the host name so that when we install our product, it actually functions correctly the way that we intend it to. You'll notice that we install MySQL. Then in the middle here, this in-between section is where we do the install suite. You'll remember that from a few slides ago. The AC apply script installs the suite. And then we have a post-apply list here, right? These are all the things that we tell our customers to do post-configuration. Torque is a resource manager that we sponsor as Adaptive Computing, but it's open source. But we lay down a resource manager. We lay down, obviously, we have a couple different DBs, MySQL and Mongo. We lay down some system tests. That's the only thing that's outside of exactly what we tell a customer to do, because we want to make sure that some of these builds pass our nose testing. MWS is Moab Web Services. We have some users that we tell folks to place. All this is automated in a property file, right? Again, giving people that ability to stand up a suite on the fly, right? On the fly, using Builder, one tool, no matter who you are in the company. An example of Java 7, or Java 7, JRE17 there. So this is what an actual init.pp file will look. That should be very familiar for you Puppet nerds out there. This is encapsulated inside of the ancillary folder, Java 7 manifest init.pp, right? This should look very familiar. And then this is a rinse and repeat, right? Obviously, the Julia Child's Kitchen here, we're usually seeing execution times in the 11-minute range. But this is what the output of mapply will look like once a developer has run it on their own individual OpenStack instance. You get down here, we'll capture a total runtime, and it'll show all the different manifests that have been applied. If there's any error here, we'll actually capture that for them and alert them to it via the standard out that Puppet's giving and its error and warning messages. Average install takes, like I said, for our most complex product, which is called HPC Enterprise Suite, has all the different variations and flavors that you can plug into it. It takes about 11 minutes or so. So just to understand, 12 hours historically of developers' time, that's a long time, right, for a developer to go through this step manually, down to about 11 minutes was a huge win inside of our organization, right? Huge time reduction. 11 minutes, it's repeatable, right? Builder is now the only way that we allow people to install our stack. It is also the approved way. We want to encourage as many people as possible to go ahead and use this way because it's supported. The property files that we looked at earlier in the deck follow our documentation that we release to customers, right? It's important that we give them our very best. And so that's one way that we can do that. And again, we created those tight feedback loops. And we know immediately if we change something in documentation or even change something in a build, if a developer changes and fixes a bug, we'll have immediate feedback. Once that build has been committed and an associated Jenkins job has run, we'll know immediately if that's been successful or not. And then because of the ability to pass command line arguments to the AC apply script, we're able to reach out in Jenkins and reach out into OpenStack and stand up these instances kind of on the fly. We do this, I'd really like to say hundreds of times a day, but we do it tens of times a day. We don't have a huge engineering department. But this is being utilized today, tens of times a day, to the tune of probably, I'd say anywhere in the range of 50 to 60 installs a day, depending on which phase of the release we're going through, which is really gratifying. Some things that I missed as I was thinking about this. Because we don't have the typical source from the puppetmaster, meaning I can't do a source, // module name, files directory, and then a file. I made an early assumption to go ahead and put relative paths in all of the ancillary manifest files, meaning that we're kind of tied to temp. It's proven to be a little bit of a limitation. The reporting is fairly basic. One of the things that the bash wrapper does after a successful run is it will report, basically do a simple curl command out to a PHP app to record things like what flavor, was it enterprise or was it basic, was it 5 or 6, and then also what the total time was on the run, and then who ran it. Obviously it's primarily always going to be root because we want to get things done, right? But we miss out on some of the reporting, right? It'd be really nice to know, or it'd be really nice to get a little bit better insight and introspection into the actual Puppet runs and how they're doing. And then, again, we mentioned this already, but who, right? If a user logs into OpenStack, Puppet runs as root, therefore we force the root user to be run when we're running mapply, right? We should be able to better escape that root user, have a sudo in there, and then be able to capture who actually ran that. So we'd like to know inside of our organization, is it Fred and Joe that keep running these and Brian's not? We'd just like a little bit better introspection into who's actually utilizing the tool. We do a survey to know how many respondents were actually using the tool, but we'd like to get a little bit more granular in our reporting there. So those are some things that were obviously missed in the tool. The tool is not perfect. No tool is perfect, right? But it's important to call those out. And so, again, as a recap, 12 hours of time down to 11 minutes, the way to install Adaptive, our product stack. The benefits are spilling over into other business groups, which is really important for us, meaning that these inefficiencies that are inside of engineering are not getting propagated to other business units. That's really important for us. We want to enable the organization instead of detain them, right? And that's about it. So thanks for your time. We'll get on to the next speaker and then let you guys get out of here for dinner. Any questions? I can be reached there via Twitter, or I'd be happy to take a question or two if you have any. All right, guys, thanks so much.